This video is about solving absolute value inequalities. And my method is going to be slightly different than the way that they do it in the book. I like to use something called GOLA, G-O-L-A. So I'm going to bring that up right now. G-O-L-A. G stands for greater than. O is or. L is less than. And the A is for and. So what this is saying is that if you have the greater than sign, you use the or. If you have the less than sign, you use the and. So let's see how this works. And again, the textbook that we're using right now doesn't use this method, but I think it works out pretty well. It's a lot easier. So if I have the absolute value of W minus 2 less than 4. The way to solve this is just as we did with the equals, we rewrite it exactly how it is. 4. Now we have to also rewrite it. W minus 2. We flip the sign from less than to greater than. Make the right hand side negative. And we're good. Now the symbol that goes here is what's important. So we began with less than, which is an L. So this is going to be an and. So if we solve this, W is less than 6 and W minus 2 is greater than negative 4. W is greater than negative 2. So on the number line, we have negative 2 is here and 6 is over here. So W is strictly less than, so we use the open circle all the way this way. Whereas W is also this way. Since we're using the word and, both of these have to be true. So the only way both of these are true is if we go from negative 2 up to 6, open circle, right there. All of those are part of both solution sets. So let's take a look at negative 1. Negative 1 is less than 6, and negative 1 is greater than negative 1. And if you put that into the original problem, negative 1 and a negative 2 is a negative 3. Absolute value of negative 3 is a positive 3. Positive 3 is less than 4. Another way to write this is interval notation. So this would be negative infinity. Nope. This would be negative 2 up to 6. With parentheses on both sides, the parentheses indicate that neither negative 2 nor 6 is part of the solution set. Take a look at this one. 3r plus 10, absolute value 4. So we're going to have 3r plus 10 less than or equal to 4. And then 3r plus 10 was less than or equal, so it's now greater than or equal. Was a positive 4, it's now negative 4. So we solve this. 3r less than 4 minus 10 minus 6. R is less than negative 6 over 3. So R is less than or equal to negative 2. This was a less than, so this is an and. So 3r greater than or equal to negative 14. R is greater than negative 14 over 3. This is an and, so both of these have to be true. Negative 14 thirds is there. Negative 2 is here. So we need r that's less than or equal to negative 2, and r is greater. Since we have the equal sign, that means we get the closed circle. So we have those points also written like this. And we use the brackets to indicate that the endpoints are part of the solution set. So these both had less than. Let's take a look at a problem with the greater than. Say 6a plus 7 is greater than 3. So we're going to have 6a plus 7 is greater than 3. This is greater, so we use the or. Then we have 6a plus 7 is less than negative 3. This is 6a is greater than negative 4. A is greater than negative 4 over 6. A is greater than negative 2/3. Over here, 6a is less than negative 10. A is less than negative 10 over 6. A is less than negative 5/3. So we get our number line, negative 5/3. Negative 2/3. A is greater than, so it's strictly greater than. So I have an open circle, less than, and since this is an or, these can happen, so I will have negative infinity to negative 5/3 union negative 2/3 to positive infinity. So that's the use of Gola. I think it works out very well, and I hope that this helps you in your homework.